Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture, and in this video lecture we will study a problem based upon the resultant of number of concurrent forces. Okay, so the statement of the problem is forces each equal to P act at a point parallel to sides of a triangle ABC. Show that their resultant is given by this one. So forces each of magnitude P are acting at a point and parallel to the sides of a triangle. So now let me first draw a triangle, then we will so this is the triangle. Okay, so you can make it a little bit horizontal. This is horizontal now, and this side. So these are the sides of a triangle, say A, B, C, fine, and the directions of the triangle in order are these are the directions. So let us suppose we have and these are the angles of the triangle. This angle is A, this angle is B, and this angle is C. So forces are acting along this direction. If I say parallel to the sides of a triangle, so if I say this is the point P, and if I draw side parallel to this one, so this is the force, okay, and parallel to this one, this is the force, and parallel to this one, so and this point at which it is acting is point O, and say these forces are acting in this direction because BC is in this, so this is acting parallel to this one. CA is in this, so this is P acting over here. This is over here, so this is also P, this is also P. Now we have to see the angle between the forces. Along this is P. If I say this is also P, this is also P, this is also P. So angle between this and this, for to find this and this, I have to extrapolate this line so that I could see this angle, and if this angle is C, so this angle will be 180 minus C. Why I have extrapolated it? Because this is converging and this is diverging, so we have to take the both diverging from point C. So I have extrapolated it and seen the angle 180 degree minus C. Away, now this line is also away from C, this is also away from C, so now we can measure the angle in the anticlockwise sense. So this angle is this angle is what I shall be writing 180 minus C. Done. Similarly extrapolate, so as to see the angle between this and this, extrapolate this one. I am extrapolating this also. So this angle is once again 180 minus A. Done. And this is angle this and this and this angle is 180 minus A. Similarly, if you see, you will have to extrapolate done, and this angle is B, so this angle will be 180 minus B. Fine. So this angle will be 180 minus B. Done. So we have all the angles, and this side is horizontal side. We can name it as X. So now I am going to resolve the forces and find the resultant. And let us say their resultant is R, and acting in this direction, making angle theta with horizontal. This angle is theta. Fine. And this is resultant R. We have to find the resultant R and prove that this is equal to this one. Now this is the figure, and if I say this is figure number 1 and this is figure number 2. Now resolving the forces, along OX, we have, so what we'll get? We will be getting P is along the horizontal, so it is making 0 angle with horizontal. This is at an angle 180 minus C. This is in this direction, so it is making 180 minus C. So this will be P cos 180 minus C. And this is making, this is 180 minus C, this is 180 minus A. So the total angle will be 180 minus C plus 180 minus A. This will be 360 degree minus A minus C. This will be 360 degree minus A plus C. So this will be P. So this angle from here to here will be 360 minus AC. So this will be P cos 360 degree minus A plus C, and this is nothing but R of cos theta, because we know that algebraic sum of the resolved part of the forces along any direction is equal to the resolved part of the resultant along the same direction. So direction in this case is OX, that is horizontal. So cos 0 is 1, cos 180 minus C is cos C, and sine here will be minus. So here sine will be minus. Fine. At 360 minus AC in fourth quadrant it is positive, so it will be P cos A plus C is equal to R cos theta. Now A plus C, we know that this is the triangle A, B, C, okay, and sum of the all three angles of a triangle, that is A plus B plus C, is nothing but 180 degree. So what will be A plus C now here? A plus C will be 180 degree minus P. So I am going to put it over here. P minus P cos C plus P cos 180 minus B is equal to R cos theta. Fine. So this will be P minus P cos C minus P cos B is equal to R cos theta. Now because we know that in second quadrant cos is negative, so it will be negative. Now once again resolving the forces along perpendicular to OX, perpendicular to OX. Resolving forces along the direction perpendicular to OX. So how will resolve? Instead of cos we will write sine. So it will be P sine 0 P sine 180 minus C plus P sine 360 minus A plus C is equal to R sine theta. Fine. So sine 0 is 0 and sine 180 minus C is sine C, P sine C, and sine 360 minus theta is minus sine theta. So this will be minus P sine A plus C. So this will be equal to R sine theta. Now using again the same, A plus C is 180 minus B. So this will be P sine C minus P 180 minus B is equal to R sine theta. Fine. So this will be in second quadrant, sign is positive. So P minus P, it will be, here is sine, na? Here is also sine. So R sine theta. So this will be P sine minus C look over here, this is R sine theta. So this will be P sine C minus P, it will be sine 180 minus B is equal to R sine theta. Fine. This will be P sine C minus P sine 180 minus B will be in second quadrant, sign is positive, it will sine B R sine theta. You are going to name this equation as 2 and name this equation as equation number 1. So now I am going to create some space. So removing from here. Now squaring and adding 1 and 2, we get, it will be it will be P, square of this one will be P square plus P square cos square C plus P square cos square B. Now this and this term minus 2P square cos C minus 2P square cos C, this and this minus 2P square cos B, and this minus minus will be plus 2P square cos C cos B, and this terms P square sin square C plus P square sin square B minus 2P square sin C sin P is equal to R square will be common, cos square theta plus sin square theta is 1. So this will be R square. Fine. Now P square is as such, cos square C is here is P square sin square C. So P square will be common, cos square C plus sin square C is 1. So this will be P square cos square B, P square sin square B, it will be again P square minus 2P square cos C minus 2P square cos B, and from this and this term take 2p square common. So take 2p square common, it will be, and you could also take minus common also. So I am going to take minus common also. This is minus, so this will be where is that term? This is positive, no? So it will be positive only. 2p square cos C cos B, and from here minus sin C sin B is equal to r square. Fine, this is equal to r square. So cos A cos B minus sin A sin B is cos B plus C. So this will be, this is 3 p square minus 2 p square cos C minus 2 p square cos B plus 2p square cos B plus C is equal to r square. And from again sum of the angles of the triangle is A plus B plus C is equal to 180 degree. So B plus C over here will be 180 minus A. So it will be 3p square minus 2p square cos C minus 2p square cos B plus, instead of this we will write 2p square cos 180 minus A is equal to r square. So this will be 3p square minus 2p square cos C minus 2p square cos B, it will be minus 2p square cos A is equal to r square. Now this will give, p can be taken outside and taking square root, this will be p and square root, it will be 3 minus 2 cos C minus 2 cos B minus 2 cos A is equal to r. Fine. So this was required to prove. See, this was required to prove. Here is 2 cos A minus 2 cos B minus 2 cos C. So that is all. This is very important question from examination point of view. Please do prepare it. And so that's all I have from this lecture. And if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, see you soon.